Distance Physics class. I'm NC Joshua. Today we'll be looking at the topic which is waves. What is a wave? A wave is a disturbance which travels from its point of origination or generation to another point and transfers energy without any permanent displacement of the medium. For instance, if I shout and you are close to me, you will definitely hear me. And if the decibel of my voice is much, there is an act that you could close your ears because I'm sending a disturbance to you by transferring energy from my point to where you are. That shows that a wave can move from one point to another and it has the ability to transfer energy from one point to another. Now, our next point is classification of waves. Weight can be classified based on different categories. The first category is based on material medium. So there are waves that require material medium to move from one point to another. We call those waves material waves, or we call them mechanical waves. What are mechanical waves? Mechanical waves are waves that require material medium for their propagation. Such a wave is water wave. Another kind of such wave is sound wave. Sound wave require air for it to go from one point to another. Where there is no air, sound won't go. For instance, in a vacuum, if I talk, you can't hear me without the help of radio or the help of a device that can assist you to hear. So water wave, sound wave require material medium for propagation. Waves in strings require material medium for propagation. We have waves that do not require such medium for their propagation. They are called non-material waves or non-mechanical waves. Such a wave can also be called electromagnetic waves. So non-mechanical waves are also called electromagnetic waves. And such waves are gamma ray, X-ray, ultraviolet ray, light wave, and you have the infrared, you have the microwave, and the radio wave. In a short form, I can call gasoline, where the ga is for the gamma ray, the X is for the X-ray, the U is for the ultraviolet ray, the L is for the light wave, the I is for the infrared, the M is for the microwave, and the arrow is for the radio wave. So another form at which we can classify wave is based on the direction of vibration. Based on direction of vibration, we have one transverse wave. What is a transverse wave? A transverse wave is a wave in which the direction of the wave is perpendicular to the direction of the vibration of the particles. I will show you a diagram to illustrate how a transverse wave looks like. So this is a sketch of a transverse wave. A transverse wave, look at the source and look at the direction. They are perpendicular. So this is the movement of the particle of the wave is perpendicular to the direction of the wave. The particles vibrating is perpendicular to the direction of the wave. Now look at this. The transverse wave has a crest and a trough. What is a crest? The upward maximum displacement is the crest, while the downward maximum displacement is the trough. Maximum displacement actually is amplitude, but the upward displacement of a transverse wave is the crest. The downward displacement is the trough. So in a transverse wave, we have a crest and a trough. But if you look at this second one, which is a longitudinal wave, a longitudinal wave is a wave is a wave whose direction of motion is parallel to the direction of the vibrating particle. So if you look at the diagram here, you have the source of the wave and you have the particle movement. So you see both the source of the wave and the particle movement, they are parallel to each other. And in this case, you don't have a crest and a trough. What you have is rare refraction and compression. So this region is a region of rare refraction. This region is a region of compression. This region is a region of rare refraction. Why this place is compression. So the place where you have much pressure is referred to as compression, while the point where the region where you have less pressure is referred to as rare refraction. Just as you have the top here called the crest and the bottom called the trough, in the case of longitudinal wave, you have rare refraction and compression. Now, what are the examples of a transverse wave? We have water wave is an example of transverse wave. Wave in strings are example of transverse wave, and all electromagnetic wave. All electromagnetic wave. Remember the gasoline, the gamma ray, the X-ray, the light ray, the infrared ray, the radio wave and the microwave. All electromagnetic waves are transverse wave. But for the longitudinal wave, we have sound wave. Sound wave is an example of a longitudinal wave. Now, under the transverse wave, we'll be looking at another kinds of wave, which are the progressive wave and the stationary wave. What's a progressive wave? From the word progressive, is a wave that spreads continuously. Such a wave is something like this. The wave just keeps spreading. It's a wave that spreads continuously. It keeps going continuously. That's a progressive wave. And another name for a progressive wave is called a traveling wave. A traveling wave. But when you come to a stationary wave, what's a stationary wave? A stationary wave is a wave that does not spread continuously. It's like a wave that is not moving. And how is such a wave actualized? Is something like this, but this time I'll show you the wave travels, but it comes to a fixed point. It comes to a fixed point. And because it's coming to a fixed point, there is a reversal of the wave. Unlike this, that there was no fixed point to the traveling of the wave, but to a stationary wave on its traveling, there is a fixed point. There is a fixed point. Now, this is how the wave traveled. This same wave is this wave. Now, on getting to this point, there is a reversal coming back here and coming back here. So if I give this as my wave one, this is the wave one, this is the part of wave one, then this is now my wave two, So this wave is a stationary wave, it's a non-traveling wave. Another name for a stationary wave is a non-traveling wave or a standing wave. And such a wave do not transfer energy. But a progressive wave is a traveling wave and it transfer energy. So one of the characteristics or the characteristics of a stationary wave is that is a stationary wave is two equal waves of same frequency, same amplitude and wavelength, but opposite in direction. So this wave and this wave have the same frequency. This wave and this wave have the same amplitude, maximal displacement. They have the same amplitude. This is the maximal displacement, this is the maximal displacement, this is the maximal displacement, maximal displacement. So they have the same amplitude and they have the same wavelength, but they are opposite in direction. This is a stationary wave, and this wave do not transfer energy.